Hello there, I am Dr. Okolugbo. You're welcome to my YouTube channel where we'll be solving problems relating to business mathematics, business statistics, analysis for business decision, as well as other related topics. I want to encourage you as you go through these videos with me, you have your paper, your pen, and your calculator to solve these problems with me. Also, please do like, share, and subscribe so that you can receive notifications for upcoming videos that we'll be uploading. Thank you. You're welcome once again to my channel. Thank you for following me this far. Today we are going to continue with our lessons or lectures on test of hypothesis. Before now, we've looked at one-tail test considering small sample. Today we are going to look at one example of a one-tail test, but we'll be looking at dealing with large samples greater than 30. And we're going to see how we'll solve the problem using different formula from the T statistic. It's about the same thing, but rather than using T, we're going to use Z, and we're going to see how we will relate that figure on our T-test table and decide what we're going to do after the test has been taken or after the sample has been taken, comparing it with the population. I want to encourage you to look at the other videos that we have made before now, considering giving you a better introduction or a prelude to what test of hypothesis is all about. Let's look at what we have for today. You're welcome. We have an interesting case on our hand here. Look at up here, we have example 4. And the question is, a sample of 157 male managers' blood pressure, that's BP, was taken with a mean of 147 millimeters of mercury. This is millimeters of mercury. And standard deviation of 27 millimeters of mercury. We wish to know if, on the basis of this data that we've collected from the sample, we may conclude that the mean BP of the population is greater than 140 millimeters of mercury at 0.01 level of significance. Normally, if you're given a question, you need to identify the key information from the question that you're given. In the case of test of hypothesis, we know that we have to identify what we call the population mean. That's the population mean. We have to also identify what we call the sample mean. We have to identify if we have a population standard deviation, that's it, or we have a sample standard deviation. These are the symbols for each of them. Then we have to also consider the number of sample from the question. These things that we identify will help us determine whether we are going to use a T statistics or a Z statistics, as the case may be. Now, mind you, we have predetermined that this is for large sample, and for this question we have a sample of 157. So we have 157, and 157 is greater than 30. Any sample less than 30 is considered a small sample. It's considered a small sample. Now we're given the number of sample at 57, and we're told that from this sample, the mean of the sample, that's it, the mean of the sample, that's the mean of the sample is 146 millimeters of mercury. Then, and the standard deviation of the sample, remember I told you in an earlier video that anytime you are given the standard deviation will usually follow the sample. If you're given a mean or a sample mean, the standard deviation will almost immediately follow the mean. If you're given a population mean and you're given a population standard deviation, the standard deviation of the population will almost immediately follow the mean of the population. In this case, we now have the mean of the sample given, and we're also given the standard deviation of the sample as 27. Then the question is, what will be the population mean? The population mean in this case is got from here. Look up here. We have the mean BP of the population is greater than 140. So 140 becomes the mean of the population. So once we've got this, we know that there is no population standard deviation given, but we are given sample standard deviation, but our sample is a large sample. The sample is a large sample. We are going to have a case of using our Z statistic. Now let's answer this question very quickly. The first thing we do is to, as I write, we have to state the hypothesis. In this case, we have the null hypothesis is given as the mean of the population, we're told, is 140. That's it. 140 millimeters of mercury. Then we want to contest this with the alternative hypothesis by saying that, may we conclude, look up here, may we conclude that the mean of the population is greater than. Now we conclude, so that means mean is greater than 140. Now, since we have a case of wanting to find whether the mean or the value in the mean, the sample, is greater, we're going to be dealing with a one-tailed test. This is the one-tailed test. If it was a case of looking for whether it is lesser, it's also a one-tailed test. But if we are looking for where the values are, we want to find whether they are equal or they are the same, then we're talking about a two-tailed test. But this hour we're still dealing with one-tailed test. So this is a one-tailed test. Now the next thing we do from our solution is to determine the Z-score, to determine what we call the Z-score, or standardize the difference. Standardize the difference. And to standardize the difference, we are going to use Z-score. Why are we using Z-score in this case? We're using Z-score because our sample is greater than 30. Even though we are given the sample standard deviation, our sample is greater than 30. And the formula for Z-score is the sample mean minus the population mean divided by, in this case, sample standard deviation divided by the mean of, divided by the root of the number of samples. So let's solve this. The mean, the sample mean is 146 minus 140 divided by the sample standard deviation is 27 divided by the root of 157. I trust you're following. Let's continue with this. 146 minus 140 is 6 divided by 27 all over the root of 157 should give us 12.53. Let's continue with this. We now have 6 again divided by 27 divided by 12.53. That should give us 2.1 0.548. That's what you should have. I trust you're following me at home, wherever you are, with your calculator and your paper to solve this problem with me. Then, if we have 6 divided by 2.1548, what are we going to have? We're going to have 2.784. So this is our Z-score. Now the question is that we want to compare this value of the Z-score with the critical value on our distribution curve. So the next thing we do is to determine critical value. Now the critical value will be determined from our t-test table. So from the t-test table, so we're going to see shortly, from the t-test table, we want to check 0.01 level of significance. Now, and then our degree of freedom. Before now, we've used degree of freedom of n-1, and that is because n is less than 30. But in this case, n is far greater than 30. So what degree of freedom we're going to what degree of freedom I'm going to use? We're going to use degree of freedom infinity. You're going to see that on the table very quickly. So let's find what this value will be, our critical value on our table. So come along with me. Let's look at our t-test table here. Can you see my table? Move closely, please. Can you see my table? Now, this is a one-tail test. Remember, it's a one-tail level of significance for one-tail test. And we're looking at 0.01. This is 0.01. Now, because our degree of freedom is beyond, you see, this 1 to, we have 30 here, and then the next one is 40, 60, but then what we have is greater than 120. So our n value is far greater. So any value that is greater than 30, most of the times we use this infinity sign, degree of freedom. Let's trace our values to what we have, 0.01. Please follow me. Look at 0.01 up here, 0.01 down here to where we have the infinity. So the critical value is 2.326. 2.326. Let's now move to our board and complete this. So this is 2.326. That's our critical value. So let's represent this critical value on our distribution curve. Here we have our mean already given as, mean is given as 140. That's the population mean. And since we're looking at something greater, so that means it's going to be on the right. It's going to be a positive test. So we have this, and our critical value is 2.326. This portion we label as the rejection region. Region. Now these ones here, this portion is acceptance region. Okay, so let's now decide whether we are going to accept or we are going to reject. Now our Z-score is 2 points. Look up here. Our Z-score is 2.784. Now we'll now compare it with this point here. We'll compare it with this point to know where it is going to be. Now 2.784 is greater than 2.3. 2.7 is going to be within here. So we will draw this, we'll draw a point here and say 2.7. 784. So what decision are we going to take? Since 2.784 is greater than 2.326 and falls within the rejection region, it means we are going to reject the null hypothesis. We are going to reject the null hypothesis that says that the population of reject the null hypothesis that says that the BP of the population is 140. We are going to reject that to say, the BP is actually greater than 140. So let's write our decision here. Usually, let's say decision. What decision are we going to take? Since Z-score 2.784 is greater than critical value 2.326 and lies within the rejection region, we will reject the null hypothesis HO. It means that there is enough evidence in the sample there's enough evidence in the sample that the BP is greater than 140 millimeters of mercury. So this is our decision. So we're going to conclude. Let me write conclusion here. Just your following. So the conclusion here is that the BP of male managers is greater than 140 millimeters of mercury. So this gives us the solution to this question. Remember how we started? You have to identify the values in your question, population, sample, and all that. Then these are the steps you need to take in order to solve this problem. I will really encourage you to go over this video again and practice it on your own, check it up on your own, and make sure you have a Theta Stable for you to do this practice. And I'm really waiting for you to send me a comment or two at the end of this video, and do not forget to subscribe to this channel. Thank you.